Hello everyone. In this lecture, I am going to solve the gate previous problem on LPP model. Let's see the problem. Consider an objective function z equal to 3x1 plus 9x2 and the constraints is x1 plus x2 less than or equal to 8, x1 plus 2x2 less than or equal to 4 and x1 comma x2 greater than or equal to 0. The maximum value of the objective function. So here we have to determine what is the maximum value of the objective function. Then this problem is given in the GATE 2014. Here objective function is maximize z equal to 3x1 plus 9x2 and x1 comma x2 are the decision variables. And the constraints are the x1 plus x2 less than or equal to 8, x1 plus 2x2 less than or equal to the 4. Let's see the solution. First step is we have to consider the each inequality constraint as an equation. For this we have to replace the inequality symbol by the equality symbol. Then the constraints equations are, first constraint equation is x1 plus x2 equal to 8 and the second constraint equation x1 plus 2x2 equal to the 4. Next second step is each constraint will be plotted on the graph by treating as equation. For this first we have to determine the coordinates of the equations. First constraint equation is x1 plus x2 equal to 8. Then we have to find the x1 value when the x2 equal to 0, that is the x1 value is the 8. Similarly x2 value also 8 when the x1 equal to 0. Then the coordinates of the first constraint is 8 comma 8. Next we have to see the what is the coordinates for the second constraint, that is the x1 plus 2x2 equal to 4. Here x1 value is the 4 when the x2 equal to 0. Similarly x2 value is the 2 when the x1 equal to 0. Then the coordinates for the second constraint is 4 comma 2. So next we have to draw a horizontal and vertical axis on the graph by treating x1 is the horizontal axis and the x2 is the vertical axis. Then we have to observe the coordinates values of the each constraints. Here maximum value is the 8 for the x1 and x2 variables for the two constraints. Then take the minimum value is the 8 and make divisions on the x1 and x2 axis and consider the 1 centimeter for the each division. Next we have to mark the first equation coordinates, that is the 8 comma 8 on the graph. Then join these points, it will give the first constraint line. Next we have to mark the second coordinates, second constraint equation coordinates, that is the 4 comma 2 on the graph and join these points, it will give the second constraint line. Next step is we have to mark the feasible region on inequality conditions of the constraints. For this, in these previous videos already we discussed how to identify the region based on the x1 and x2 coefficient values. Here coefficients of the x1 and x2 decision variables are positive for the first and second constraint equation. Then we have to mark the region based on the inequality symbol. If the inequality symbol is greater than or equal to 0, then we have to consider the region is above the line. If the inequality symbol is less than or equal to, then we have to consider the region is below the line. Here both of the constraints are having the positive coefficients of positive quotient values for the x1 and x2 variables, and also having the less than or equal to the symbol. Then we have to consider the region is below the line for the two constraints. And so here we have to identify the feasible region. Here feasible region is OAB. Feasible region is which is bounded by the all the constraints. Here feasible region is OAB, and the coordinates of the extreme points on the feasible region is, that is for the O 0, 0, for the A 4, 0, for the B 0, 2. Next we have to substitute these points in the objective function, that is the z equal to 3x1 plus 9x2, and we will get the values are the 0, 12, 18. So among these values maximum value is the 18. So maximized objective function is 18. So answer is the 18. Thank you.